right, welcome to your screencast on how to practice with force vectors. Just a reminder, a vector is some sort of quantity in science that direction is important. If you think about when we did the bowling ball with the broom, it was very important for the motion of the bowling ball which direction you applied the force. Okay, force is a vector quantity. So in order to completely describe the force acting on something, it's not only how much force, but what direction you're applying it. Okay, force is not the only vector quantity that we're going to talk about, but that's what the emphasis is today. Remember, acceleration is also a vector quantity. Velocity is a vector quantity. Other things like momentum and weight are vector quantities. And that just means that direction is important when we talk about those things. All right, so here I am on the vector practice follow along, and I'm actually going to start back here with a few that are a little bit simpler. So we are actually maybe going to work our way backwards. So join me on the back where it says number 6 and number 8. Okay, so these are just really simple drawings trying to illustrate what is going on force-wise on a certain object, and the object is just represented by a box. All right, so for number 6, we have a box and there is a 5 Newton force being exerted on it, oriented to the left, and there's a 25 Newton force exerted on the box, oriented to the right. And when arrows are drawn with the heads of the arrows away from the box, I kind of think of those as like pull force. Maybe somebody's got a rope and they're pulling in this direction with 25, and maybe somebody else is pulling in this direction with only 5 newtons. Well, these two forces are acting in opposite directions, so I am going to subtract them. So 25 minus 5 is 20. And the net force is going to be in the direction of the bigger force. So there is a net force acting on this box. It is 20 newtons, and the net force is 20 newtons to the right. Remember, stating the direction is important when you're talking about force. Now, and then it says acceleration, question mark. Well, yes, this object will accelerate. And it's going to accelerate to the right, because acceleration is always in the direction of the net force. Acceleration is in the direction of the net force, okay? Not necessarily an object's movement, but the way that acceleration is oriented. Okay, the other thing is, I'm not telling you exactly how much acceleration there is because we're missing something, okay? Previously, you guys learned that acceleration was a change in velocity divided by a change in time. And that is absolutely true. But here, I don't have any of that. I don't have velocities and I don't have times. In this situation, you can use another strategy to find acceleration, and that is knowing the net force and then dividing it by mass. In this situation, our net force is going to be 20 newtons. Unfortunately, we don't have a mass, so I can't tell you exactly how much the object is accelerating, but I do know that it is, and I know which direction the acceleration is oriented, okay? To the right. All right, so that does it for number 6. Let's go to number 8. Again, I have two forces. One you can kind of think of as a pull force up, 5 newtons, a pull force down of 20 newtons. They are pointing in the opposite direction, so they are going to be subtracted. So 20 minus 5 is 15. The direction of the bigger force is going to be the direction of your net force. So 20 minus 5 gives you 15. And of course, the net force is in the direction of the bigger force. Okay. Acceleration. Will this object accelerate? And the answer is yes. Which way will the acceleration be oriented? It will be oriented down. Now, again, I can't tell you how much the object accelerates because I don't know mass. I know my net force, So I do know that there is acceleration. I know that the acceleration is oriented down, but unless I know mass, I can't figure out exactly what the acceleration is number-wise. Okay, so let's go up to 5 and 7. Here on number 5, I have two forces. I can think of this one kind of as a push. So somebody maybe is pushing the box down with 15 newtons, and maybe somebody else is pulling the box down with 10 newtons. It's not which side of the box the arrow is that's important. It's which way the arrow points that is important. So this arrow points down. This arrow also points down. So they are oriented in the same direction. And this time I'm going to add them. So 15 newtons down plus 10 newtons down is a total of 25 newtons down. So is there a net force that's not zero? Yes. Therefore, will there be acceleration? Yes. And the acceleration will be oriented down. Okay. Again, if I wanted to know what the acceleration was, I would say net force divided by mass, but unfortunately, I don't have mass. So I can say, yes, it's accelerating, but I just don't know how much. Okay, so whenever I look at arrows, for me personally, when the head of the arrow is against the box or the object, I kind of think of that as a pushing force. When the head of the arrow is away, I kind of think of that as a pull force. Maybe that'll help you guys. So number 7, we've got 3 forces. We've got a pull force of 5 newtons to the left. We've got a pull force of 10 newtons to the left, and we have a pull force of 20 newtons to the right. Well, these two guys, that would be the same as having a single 15 Newton force to the left, and I have a 20 Newton force to the right. Those are pointing in opposite directions, so I say 20 minus 15. My net force is 5 newtons. The bigger force wins, so the net force is 5 newtons to the right. Okay. Will this object accelerate? Yes, it will. Again, I can't tell you how much because we need to know mass for that, but it is going to accelerate, and it will accelerate to the right. All right, join me on the front. All right, we're actually going to tackle number 4 next. I have a pulling force of 10 newtons to the left. I have a pulling force of 10 newtons to the right. Well, this time they're in opposite directions and they're equal and opposite, so they completely cancel each other out. So this is 0 newtons. I put a slash through it so it doesn't look like the word on. 0 newtons. And if it's 0 newtons, you can't put a direction because it's 0. There's no direction. In this case, forces are balanced. Are balanced. So is there acceleration? No, because forces are balanced. Now, careful. Could this object still be moving? And the answer to that is yes. But is this object going to be accelerating? And the answer to that is no. So this object could be moving, let's say, at a constant velocity. It just can't be changing the way it's moving, because changing the way it's moving is acceleration. It can't be speeding up, slowing down, or changing direction. Okay?